spacecraft, the astronauts preset the timer, enclose themselves in capsules, and fall into a deep hibernation that'll carry them several hundred years into the future. This is a familiar scene in many sci-fi films, but could humans ever actually hibernate in real life? Researchers interested in this question turn to the animal kingdom, where hibernation is commonplace, occurring in over 200 species that we know of. Take the Arctic ground squirrel. Native to the North American tundra and northern Russia, this animal burrows beneath the permafrost and slips into a state of suspended animation, its body temperature plummeting to a frigid -2.9 degrees Celsius. Others, like the female black bear, can multitask, giving birth and lactating while they're hibernating through the winter. The fat-tailed dwarf lemur prepares for its long dormancy by gorging on food and storing the majority of its fat reserves in its tail, doubling its body weight. After hibernation, it emerges looking as svelte as ever. So why do these animals go to such extremes? Hibernation is a necessity, a survival tactic for making it through the harsh winter months when dwindling food and water reserves threaten survival. For many years, experts believed hibernation happened only in Arctic and temperate environments. But more recently, they've discovered animals hibernating even in arid deserts and tropical rainforests. As hibernation kicks in, animals' heartbeats usually slow to about 1 to 3% of their original speed, like the dwarf lemur's, which drops from its usual roughly 180 beats per minute to just around 4. Breathing also declines dramatically, to just one breath every 10 to 21 minutes in the lemur's case. And black bears, like most hibernators, don't urinate or defecate the entire hibernation season. Hibernating animals appear to stay alive by having just enough blood and oxygen moving around their bodies. And scans of hibernating animals reveal that their brain activity has just about flatlined. But hibernation isn't a long winter's nap. As far as researchers know, in lemurs and ground squirrels anyways, the animals aren't even sleeping for most of it. Hibernation is actually made up of regular bouts of reduced metabolic rate and body temperature, known as torpor. Animals can be in torpor for a few days to 5 weeks, after which they resume normal metabolic rate and body temperature for about 24 hours before going back into torpor again. The phenomenon is known as an interbout arousal, and why it occurs is still a mystery. The behaviors inherent in hibernation, like going 5 weeks without sleep or dropping to near-freezing body temperatures, would be potentially fatal to non-hibernating species like us. To find out how hibernators are able to do this, researchers turned their attention to those animals' genomes. So far, they've discovered that hibernation is controlled by genes that turn off and on in unique patterns throughout the year, fine-tuning the hibernator's physiology and behavior. For example, ground squirrel, bear, and dwarf lemur studies have revealed that these animals are able to turn on the genes that control fat metabolism precisely when they need to use their fat stores as fuel to survive long periods of fasting. And the genes in question are present in all mammals, which means that researchers could study hibernating mammals to see how their unique control of physiology might help humans. Understanding how hibernators deal with reduced blood flow could lead to better treatments for protecting the brain during a stroke. Figuring out how these animals avoid muscle deterioration might improve the lives of bedridden patients. And studying how hibernating animals control their weight with ease could illuminate the relationship between metabolism and weight gain in humans. And yes, more research in this area might someday make human hibernation a real possibility. Imagine our surprise if the key to intergalactic travel turns out to be ground squirrels, black bears, and dwarf lemurs. Thank you so much to everyone who has supported our nonprofit mission on Patreon. If you want to learn more about how to get involved, check out our Patreon page at patreon.com/TEDEd.